Good morning, students. Once again, I welcome you to my video lectures on signals and systems. So today I will work out problems on finding inverse z-transform. First problem, you take first problem. First problem, x of z is equal to 2z by 2z minus 1. 2z minus 1 plus 2 divided by z over 2z divided by 2z minus 1 plus 2 divided by 1 minus 2 by z. 1 minus 2 by z. 1 minus 2 by z. Or one thing, on 2z. 2z over 2z minus 1 plus 2z by z minus 2 to mod z greater than 2. This is first problem. Now in this problem, this is already expanded using partial fractions. See in the denominator you will see 2z minus 1 is a factor, z minus 2 is a factor. So in the problem, already it is being factorized. So in the next problem I will do factorization, not now. In this problem, first bring it to standard form. If you bring it to the standard form, so here take out, because standard form is of this z by z minus 1, z by z minus alpha. It is standard form. It is not so. So what you do, 2z divided by, take out 2 outside, 2 into z minus half plus 2 z by z minus 2. Z minus 2 with mod z greater than 2. So 2 get cancelled, z. First, so for the whole problem, this is ROC. This is ROC. You can now take the first term, z over z minus half. Z over z minus half. Which is the form here? It is this form. Z over z minus alpha. Here in the first one it is 1, but it is half. So z by z minus alpha. So z by z minus alpha, where alpha is half. So this is the form. This is the form. Now having chosen the form, now next, what about this one? Now we shall write. Before writing, you have identified this. Next, this one, 2 into z by z minus 2. 2 into z by z minus 2. 2 into z by z minus 2. So this is also of this form. This is also of this form. Now the question arises. What is the term? So here, what about the ROC here? The ROC here for this case is mod z greater than alpha. Mod z greater than alpha. So here for this one, ROC is mod z greater than alpha. Mod z greater than alpha. Whereas here, mod z for this term, ROC is mod z greater than 2. Mod z greater than 2. Now to write the sequence, so here I will sketch the ROC. So this is what is called as half, and 2 here, they are called as poles. So z equal to half is a pole, z equal to 2 is called as a pole. So first in this case, z equal to half is a pole. Construct a circle. Whereas here ROC, the pole is at 2. The pole is at 2. Now having sketched the poles for these terms, now you take ROC of the whole problem, because this has to satisfy what is known as linearity. We have come across linearity property. So z greater than 2 applies to both. So mod z greater than 2. So this is half. So to the right, to its right, to the pole radius right, we have ROC. ROC is mod z greater than 2. Mod z greater than 2. Now, if ROC is greater than the pole radius, then it is to be right-sided sequence. So we have to write right-sided sequence for this. Whereas for this term also, z greater than 2. Z greater than 2 means outside this circle, because this radius is 2. So z greater than 2, pole is here. Pole greater than pole radius, ROC, has got or is larger than the pole radius here. Therefore, for this one also you are supposed to write the right-sided sequence, because it always exists for right-sided sequence. Therefore, looking into this, you can write the terms for these two. First one, x of n is equal to, here it is half. So half, alpha is half. So half multiplied with to the power of n. Half to the power of n, half to the power of n, u of n, half to the power of n, u of n. Next, plus 2. 2 is a constant, and here it is 2. Alpha is 2. Therefore, alpha is 2 to the power of n, u of n. 2 to the power of n, u of n. So this is what is known as inverse z transform using partial fraction. So in this problem, you have already problem is given in the form of partial fraction expansion. This is called as partial fraction expansion. In the denominator, you will find factors. And for this problem, you wrote what is known as xn. In the next class, I will take up the problems where you are supposed to do partial fraction expansion. Thank you.